at which x values does y equals 3x minus 1 to the power of 4 times 7 minus 2x to the power of 5 have a horizontal tangent. So our approach in this question is going to be to find the derivative of the following function. Once we have the derivative, we're going to set the derivative y prime equal to 0 because the horizontal tangent has a derivative of 0. Then we're going to solve it for the x values at which the derivative is 0. Okay. Now if we take a look at this function here, it consists of a product of two composite functions. So for each one of those composite functions, we will have to use the chain rule to differentiate it. And then for the product of the two composite functions, we would have to use the product rule. So let's start by applying the product rule. So y prime equals, so for the product rule, we're going to first differentiate the first function. So 3x minus 1 to the power of 4 prime times the second function plus the first function times the derivative of the second function. Like that. So we've applied the product rule. Now, in order to take the derivative, I forgot something. We are taking the, this is not 5 here, should be there, and it's the derivative. Okay. So to take the derivative of the two composite functions, we are going to now apply the chain rule. So the derivative of the outside function here is going to be 4 times 3x minus 1 to the power of 3 times the derivative of the inside function. Times 7 minus 2x to the power of 5. And now again, the derivative of the outside function is 5 times the inside function to the power of 4 times the derivative of the inside function. Like that. In the next step, we're going to take the derivatives of those two inside functions. So 3x minus 1, the derivative of that is just 3. The derivative of 7 minus 2x is negative 2. And now if we take a look at this, we essentially have two terms. We have this entire term here plus this entire term here. Each term is a product of several factors. We're going to clean this up a little bit now. We're going to drop those square brackets. We're going to multiply those binomials together and rearrange it a little bit. So 4 times 3 is 12 times 3x minus 1 cubed times 7 minus 2x to the power of 5. So that's essentially the first term plus, and we're going to combine these two terms. 5 times negative 2 is negative 10, so actually it's not going to be plus. It's going to be minus 10 times 3x minus 1 to the power of 4 times 7 minus 2x to the power of 4. Like that. So this is the derivative of the function. Now we're going to set this to equal to 0 But in order for us to be able to solve a complex expression like this, we would like to try and factor it, because if we can factor it, so we just end up with a series of factors that are multiplied, we can use the zero product theorem to find the roots. At this point we can't. Now this is going to be a bit tricky to factor, so to help me along I'm going to define two variables to help me along. So a is going to be defined as 3x minus 1, and b is going to be 7 minus 2x. Okay, so now I can write this as 12 times a cubed times b to the power of 5 minus 10 times a to the power of 4 times b to the power of 4. And now we can see that there is a greatest common factor. We can factor out 2 a cubed and a b to the power of 4. That's our greatest common factor, which means that I'm left with 6b minus 5a. So now we can substitute a and b back into this expression to get the full expression. So it's going to be 2 times 3x minus 1 cubed times 7 minus 2x to the power of 4 times 6 times 7 minus 2x minus 5 times 3x minus 1. And I'm actually going to use square brackets here to differentiate them. Okay. So at this point we have just this binomial in here. We're going to expand these two products here and simplify a little bit. So we have 2 times 3x minus 1 cubed times 7 minus 2x to the power of 4. If I multiply the 6 into the bracket, I'm going to get 42 minus 12x. Same thing over here, negative 15x plus 5. Like that. And then we can combine some like terms here, which is going to leave us with 2 times 3x minus 1 cubed times 7 minus 2x to the power of 4. And in this bracket, I'm going to have 42 plus 5 is 47. And then negative 12 minus 15 is negative 27x. Okay, so at this point we have achieved what we set out to do. We have expressed the derivative of that original function as a series of factors. Okay, so at this point what we are going to do is we're going to equal this to 0. So we're going to go 2 times 3x minus 1 cubed times 7 minus 2x to the power of 4 times 47 minus 27x equals to 0. And now we can use the zero product theorem to solve this. So this product here will be 0 either when 3x minus 1 equals to 0, okay, or when 7 minus 2x equals to 0, or when 47 minus 27x equals to 0. You can't see that at the far end, so I'm going to see if I can move this. It's a little bit better. Let me move it a little bit more. Like that. Okay. So there are sort of these three scenarios here. And we just have to determine for what values of x each one of these factors would equal to 0. This one here would equal to 0 when we have x equals 1 over 3, a third. This factor here, x will equal to 0 when x equals 2 over 7. No, 7 over 2, sorry, the other way around. You subtract 7 divided by negative 2. So it's going to be 7 over 2. And finally over here, x will equal to 0 when we have when it equals to 47 over 27. Okay, so these are the three roots. These are the values for x at which point the function, the original function, has a horizontal tangent.